Welcome, everyone, to The Explainer. Okay, today we are digging into what I can literally only describe as an absolute digital archaeological heist. We're going to look at how developers are pulling ancient historical number theory straight out of the vault to solve the modern blockchain gas crisis. If you've ever wondered how the true next generation of decentralized finance is fundamentally rewriting the laws of computational physics, well, you are in the exact right place. So right off the bat, I want you to keep this massive, honestly kind of crazy question in the back of your mind as we go. How do you do complex trigonometry on a computer that literally can't understand decimals, right? This is what developers call the trig wall. You see, the Ethereum virtual machine, the EVM, strictly demands absolute determinism to maintain consensus. If you ask 10,000 nodes to calculate a continuous, infinite decimal curve and they all round it off even slightly differently, consensus violently breaks. Billions of dollars would just vanish. So how on earth do we get around this wall? Okay, let's dive into this. Here is our heist blueprint. First, the AMM floating point crisis. Second, inside square root integers. Third, Burgi and the copper ratio. Fourth, division-free integer recurrences. And fifth, the gas-efficient future. I promise you, every single step here leads directly to eliminating that expensive, non-deterministic floating point math.
All right, part one, the AMM floating point crisis.
To really wrap our heads around this, we need to personify the hardware that's running inside your computer right now. On one side, we have the FPU, the floating point unit. The sources basically call this guy the FPU gambler. It's incredibly fast, sure, but it's lossy and it's probabilistic. It uses secret seed tables to essentially throw darts at a board, just guessing its way through complex decimals. But on the exact opposite side, we have our deterministic hero, the ALU surveyor, or arithmetic logic unit. The surveyor demands uncompromising mathematical truth. 1 plus 1 is exactly 2, every single time, on every single machine on Earth. So what happens when automated market makers, AMMs, try to force continuous curves into discrete floating point approximations, like Uniswap's 1.001 step ticks? Well, they're relying on that FPU gambler, and this causes what experts call the wood chipper effect. Because the hardware is just guessing at the math, it acts like a giant digital blender. You get massive gas spikes, compounding rounding errors, and you open up the entire liquidity pool to brutal exploits like dust grinding, where bots just siphon off fractional value from those tiny rounding errors. Which brings us to step 2 of the heist, inside the square root integers repo. This repository on GitHub is where the whole thing really clicks together. Developers discovered a brilliantly elegant shortcut based on a 2019 discovery by Kyle McLean-Smith in the Online Encyclopedia of Integer Sequences. Instead of using gas-heavy double sequence methods to approximate those messy irrational numbers, they found a way to use a single linear integer recurrence. So by feeding the contract a super simple input like 1, 1001, 2, they natively generate that exact 1.001 tick multiplier using nothing but pure integers. It is literally a trick unlocked by ancient mathematics. And you know, the absolute kicker here is how insanely accurate this gets and how fast it does it. By using just the integers 10,202 over 10,001, this sequence hits a minuscule 0.00485% error rate. That completely showcases the sheer power of pure integer fractions. You bypass the sloppy guessing of the FPU entirely, and you execute natively inside our hero, the deterministic ALU. Let's dig deeper in section 3, Burgi and the copper ratio. Because actually, scratch that. This isn't just new code. The square root integers repo is powered by literal centuries of math. We are time-traveling back to 16th century Swiss watchmaker Jos Burgi and his progress tables for scaling. Then, fast forward to the 1990s, where mathematician Vera de Spinadel categorized this exact scaling in her metallic means. And today, developers are actively translating these historical frameworks directly into smart contracts for AMM quantascale. The ultimate weapon here is the copper ratio. Part of Vera de Spinadel's metallic mean family, this specific ratio provides the exact algebraic framework needed to generate those division-free integer recurrences for AMM tick spacing. Because it can be perfectly simplified using just the greatest common divisor down to exact massive integer fractions, it completely replaces the need for irrational decimal numbers on chain. We are quite literally swapping out sloppy decimals for perfect historical integer ratios. All right, moving right along to part 4, division-free integer recurrences.
To actually pull this off in the real world, we have to adopt what's called the quantascale philosophy. Quantascale treats these price increments as emergent recurrence grains. Instead of seeing prices as blocky, arbitrary steps or industry ticks, it treats them as the natural, granular, Brownian fabric of the market itself. We're elevating our thinking directly to the atomic level of digital physics. The sources outline a brilliantly simple three-step paradigm to replace those continuous curves with exact, pixelated grids. First, you anchor the base to A equals 1, which they call side A normalization. That straightens the curves right out. Second, you swap out messy trigonometry for discrete reciprocal shifts across a rational lattice. And third, you use global remainder tracking, or GRT, to natively track the exact mathematical leftovers, ensuring literally zero data is ever lost to rounding. So by mapping this circular geometry into Pelsymith rational coordinates, the system uses complex math, like Chebyshev polynomials, as a simple translation layer to snap messy continuous angles to a strict pixelated grid. We kick out those vulnerable division operations entirely. We replace them with simple integer products known as Brahmagupta groups. No divisions, no square roots, absolutely zero FPU guesswork. Just pure, bit-perfect orientation secured right in the ALU. And finally, Section 5, the gas-efficient future. To see the real-world physical payoff of this mathematical heist, just look at this benchmark data from LimeChain comparing the legacy EVM to the Arbitrum Stylus WASM environment. When you feed these exact integer recurrences into an environment like WASM, the performance differential is just staggering. WASM completely crushes the EVM. It's over 10 times faster for integer arithmetic and over 100 times cheaper for loops and string operations. The ALU surveyor absolutely dominates here. When you stack this exact integer geometry inside these next-generation virtual machines, it yields an astonishing 74 times reduction in metabolic energy compared to legacy floating point calculations. Think about that. That isn't just a tiny iterative improvement. That is an absolute paradigm shift for decentralized networks. Because we totally demolished that trig wall and stopped forcing the hardware to guess, we hit a hard physical limit. The metabolic cost of computing drops off a total cliff, achieving an absolute hardware energy floor of exactly 0.05 picojoules per operation. And honestly, the security benefits are just as wild. This system safely scales by collapsing chaotic trading paths into stable mathematical attractors using a concept called Leonardo dynamics. The coordinates are forced into a geometric lock-in, bouncing safely between stable integer pairs like 35 and 59. This strictly stops numerical drift cold, mathematically immunizing the liquidity pools against those nasty sandwich attacks and rounding exploits. And this brilliantly illustrates the overarching victory of our exact ALU surveyor. To quote the architectural documents directly, by using this integer math, we move from simply guessing or approximating a curve to entirely possessing the state of the manifold. We have completely liquidated the informational debt of the FPU. So we've traced this unbelievable journey, right? From the frustrating limitations of the trig wall, through the historical brilliance of Burgi and Verdi-Spanadel's copper ratio, all the way to a 74x energy reduction using pure integer recurrences. The semiotic bridge is now wide open. So I want to leave you with this final provocative thought. Now that you possess absolute mathematical truth, what are you going to program physical reality to do? Thanks for joining me for this explainer. Keep learning, and I will see you next time.